Review Book A advertises an average SAT gain of 40 points with a standard deviation of 12 points. And Review Book B claims an average SAT gain of 35 points and a standard deviation of 15 points. Assuming both assertions are correct and assuming normal distribution, which review book is more likely to result in an SAT gain of over 60 points? Review Book A because of its greater mean. Review Book B because of its greater standard deviation. For both plans, the probability of an SAT gain over 60 points is 0.04779. For both plans, the probability of an SAT gain over 60 points is 0.95221. The problem cannot be solved by the information given. So, the first one is 40 points with a standard deviation of 12. The second one is 35 with a standard deviation of 15. So let's see if you guys can do that. So what do we think the answer is? C, for both plans, the probability of an SAT gain is over 60 points. Okay, let's see. So we think it's C. It is C. In both cases, 60 points is 5/3 standard deviation from the mean with a right tail probability, probability of 0.04779. How'd you guys do it? What did you do?
You have to plug each one into the equation.
Into the z-score?
Yes.
Did you plug it into the z-score?
Yeah.
Okay.
Technically, if you look at it, technically you don't even have to plug it into the equation though, because.
Well, some people like to plug it in. You don't technically have to do it, you're right.
For that problem.
Yeah. Some people don't. So, yeah, you're right. You don't have to, but if you did, that's how you would do it. You would plug it in the z-score. Okay, you ready? That was one. I'm missing some. I'm very upset because of that woman. I don't know who that woman is, but she needs to put stuff back. Which of the following are true statements? By the law of large numbers, the mean of a random variable will get closer and closer to a specific value. The standard deviation of a random variable is never negative. The standard deviation of a random variable is 0 only if the random variable takes a lone single value. So which one of those is true? Okay, what do we think it is? Oh, you guys don't want to tell me.
I'd go with either A or E or more than A.
How many people pick A? Okay. Drum roll, please. It is C. The mean is unchanging, fixed number. The law of large numbers gives that the average of observed x values tends to be closer and closer to the mean after more and more repetitions. The standard deviation is the positive square root of the variance. The only way that the variance would be 0 is if every observation was the mean, right? So, and we learned about the standard deviation all being 0 only if they were the same in Unit 1. Okay? Next one is this one. So, a television game show has 3 payoffs with the following probabilities. What are the mean and standard deviation of the payoff variable? So we did practice this a little bit on Friday. So is it, well, so we know that the mean is either A or B. So it's 375, so it's either A or B. What didn't they do on C and D, you guys?
They didn't multiply by the probabilities.
They didn't multiply it by the probabilities. Okay, so it's either 361 or 1083. So how many people think it's A? How many people think it's B? How many people haven't determined an answer yet?
That's a lot of work. I'm lazy.
You have a calculator, Lucas. You have a calculator. The answer is going to be B. So the mean was 375, and then to do the variance, you take each individual observation, subtract the mean, square it, and multiply it by its standard deviation. You don't have to divide it by anything like we usually do, because we're taking care of it as being weighted by that probability. Okay? Good? Are we good with that one? Okay. Here we go. How many people think that this answer is A, B, C, D, E? You have no idea.
I said C.
You said C. Okay. So, how do you find the mean? Let's talk about that. How do you find the expected value? Oh, here, I'm going to show you. So, remember, you're going to take each value. So, for them, 1,500 times 0.15, because that's minor accident. 8,000 times 0.05, because that is a major accident. So, you have $625. The company can expect to make 900 minus 625 because they charge everyone for $900, right? So if they have to pay out 625, that's $275 per policy, and then they had how many policies? 10, so you have to multiply it by 10. So again, you guys, you have to take that and count that 900, but the expected value again was each probability multiplied by its amount, add them together, and then multiply by 10. Let's see, do we have time to do one more? The way you guys are going, maybe not. You guys aren't really talking to me. Makes me kind of sad. Okay, let's put that. The yearly average rainfall along the coast of Liberia, I know how to say that, is 210 inches. What is the standard deviation if 20% of the years have rainfalls under 200 inches? Assume yearly rainfalls are normally distributed. So what do you got? Okay, so the answer for this question is, it is C. So the critical z-score is negative 0.8416, thus 200 minus 210. And the standard deviation is 11.88. Thanks, guys.